Last time, I pressure tested a quartz glass sealed aluminum cylinder at 328 feet deep for 2 hours. No cracks, no leaks, just pure underwater glory. This time, I'm building an underwater camera. No fancy machining, no precision seals, just vibes and aluminum. First up, 8 mm thick quartz glass hour lens, shield, and waterproof barrier. Then, a 3 mm aluminum shell to house the camera like royalty. Next, a 3D printed spacer to keep the quartz from kissing the lens and to block rogue epoxy from photobombing our footage. A cable penetrator seals the cable exit like a submarine hatch. Then comes the camera module. Small, mighty, and fully ready for the chaos ahead. And finally, the cable, because yes, even monsters need data. First, I doled the power cable from the camera, just clearing the stage for what's next. Then, to save space, I shortened the cable penetrator using a lathe. And yes, the lathe scene is long, because nothing screams engineering drama like aluminum slowly surrendering to high-speed steel. The chips fly, and the tool sings its metallic lullaby, all for a few millimeters of clearance and a whole lot of cinematic tension. After the lathe finishes its slow-motion battle, I remove the freshly shortened cable penetrator. But it's not ready for prime time, yet those burrs are sharp enough to insult the lens. So I bring in the hook blade and the mighty file to smooth things out, calm the chaos, and give this part the dignity it deserves. With the cutting done and the burrs tamed, it's time for a spa day. I grab some carburetor cleaner and give the aluminum parts a refreshing blast, because nothing says ready for epoxy like degreased, slightly offended metal. Time to assemble the cable penetrator. I lube it up with silicone grease. Smooth, confident, ready to seal. Then, oops, the nut refuses to fit into the aluminum shell. So I grab a file and give it a little attitude adjustment. Now it slides in like it was born for this. Tighten the nut, seal the deal. Engineering justice has been served. Grab your heat shrink tubing, because things are about to get toasty. Time to solder the camera module's data lines to the waterproof cable, like a high-stakes spaghetti junction. Once that's done, we gently thread the freshly welded cable through the cable penetrator and into the aluminum shell, like feeding noodles to a robot with trust issues. And finally, we solder the power wires, because no drama is complete without a proper power-up. Next up, the thermal silicone pad, our unsung hero. It channels heat away from the camera module like a tiny spa towel without shorting anything out. Pair it with some thermal adhesive, and boom, the camera is locked into the aluminum shell like it's checking into a 5-star bunker. Plus, it makes the later potting process way easier. No wiggling, no drama. For all my fellow perfectionists out there, this one's for you. I randomly grabbed a Thai herbal balm jar, and guess what? It fits the aluminum housing like it was born for this role. Snug, centered, and hands-free. Now I can let the silicone cure in peace without standing there like a human clamp. And now, entering the scene with dramatic viscosity, epoxy resin.
Jeez.
Once the epoxy is fully mixed, we pour it into the cable penetrator, like sealing a secret passage with molten armor. Flame degassing is crucial, because tiny bubbles might look cute, but they ruin waterproofing like drama ruins teamwork. Once the resin has cured, we gently remove the Thai herbal balm jar and check if the silicone inside has fully set. If everything's solid and drama-free, it's time to brush fast-curing epoxy onto the camera lens threads. This locks the lens in place, seals the optical path, and keeps the final potting resin from sneaking into places it shouldn't, like a nosy cat in a server room. Unfortunately, I didn't record the bonding process between the quartz glass and the 3D printed spacer. I used fast-curing epoxy and made sure the center of the quartz stayed clean. The fast-curing epoxy worked great. It bonded the lens to the 3D printed spacer and set quickly. And now, one last appearance from our trusty epoxy. Using a syringe needle, I inject it through the gap between the quartz and the aluminum shell. The goal? To seal the camera module completely. No water, no mercy. By the way, don't forget the final flame step for bubble removal. Everything's done. Time to test if it works before we hit the pressure tank. Everything went smoothly and it's working fine. Hopefully it survives the 328-foot pressure test. In the next video, I'll try building a GPS module for surface navigation using SLA printed parts, designed to withstand 328 feet of water pressure. Hope you enjoyed the video. Please subscribe to my channel. Your support means the world to me. See you next time.